Hello, everyone. Thanks for tuning in to a new After Dinner Mint series titled Behind the Code. On the show, we welcome Art Blocks artists to share a deeper look into their project's creative coding and process. Today, we welcome Phil, who joins us to speak about his project, Zupermat. For those watching in the future, we'll have timestamps and notable links from today's episode in the video's description. Welcome, Phil. I'll let you take it from here.
Thanks, Bonte. Thanks a lot. Thanks for the invite. It's a great opportunity to talk about Zupermat from inside. And I have a quick intro, which I'll get to, and then just to tell you how the project started, what influenced me, how I went about creating Zupermat, and then we'll jump into the code. And I have about probably three aspects of the code base I want to share that I think are interesting. And and then if there are questions, I'll be happy to answer them. I'll just stop my cam, give this presentation a chance. So Zupermat, it's an art block series that came out earlier this year, about in May 2022 on Art Blocks, and it's a 3GS series. It's three-dimensional, and it started when the aim really was I wanted to convey a sense of simplicity and calmness through a very simple visual language. And so I went with monochromic color palettes, and eventually added animation to give it more depth. And as well, the animation is something that I wanted to keep very, very calm and to serve the piece. So yeah, I have a little Figma here that I put together with screenshot I took along the way, just to share my process. So the first aha moment came when I saw this. I was playing with blocks and I was interacting with shapes in 3GS, and I saw this kind of snowy figure that had this monolithic halo to it, and it was bluish. And then it was dead of winter, and then this whole winter theme came through. And so that's the first moment where I said, well, I really have something that I feel like working on. And another theme that was really present with me was Malevich's paintings, which are surprisingly 100 years old now. The composition, the sizing, everything about them was very attractive to me. And you'll see definite echoes of this in, say, the sizing and the positioning of objects in Zupermat, and even the name is borrowing from suprematism. And then really early on, I came into the composition with multiple rectangles, and I played around with color. You see the top right there is colored blocks, which I decided to drop. And then I worked with lighting, and I tried to make the whole thing balanced and aesthetically pleasing. And then, yeah, so I initially had this idea in my head. I wanted to take, Malevich's painting and blow them up in 3D. And as I was on Robston, a fellow artist on Art Blocks, Daniel Lefcourt, he shared with me this amazing website with pictures of architectural work that Malevich had done. So I was really impressed, and I thought, wow, he's done it already. So I'm beat. But it was as well really inspiring to see this and to see that there's something to pursue anyway. And then, yeah, the last piece of work I did was animation. I probably spent half the time on finding the right balance for animation and having something that I felt was interesting. And then there's Marfa coming up. So I dug into Donald Judd and Morris, and then I saw these images that echoed Zupermat, which is really interesting, but it's really something that I discovered after, and I wish I'd really pursued this earlier, because it's really interesting. I think would have made Zupermat probably a deeper piece. So I will not hijack this behind the code session with art stuff, but so let's jump right in. I think I have a little, yeah, here it is. So what the three parts of the code I want to get into are composition. So it's really simple. Idea behind composition is throwing rays around the space and stacking shapes. So there's just a way of not having the shapes be on each other, so they kind of find their space and they grow into the space. The second topic is lights and color. So I'm gonna talk about how I decide to color the piece and how it's not really colored. It's all white and it's lit by different and the challenges I had doing this. And then the third piece, which I think is probably the most interesting, is animation. We'll see, depends. So, all right, so let's jump right in. Composition. Let's start this. Let's start Zupermat. So here we are. Wrong browser. Let me bring this up. And this is it. So it's just randomly generating a new one every time. So you'll see different ones, and we'll play with the. I'll play with the randomness, and I'll hard code stuff just to show you different aspects of it. So let's stop the animation just to start, just to look at composition first. So here's the headless, a little trick that allows me to make a preview print without rendering all the time. And so let's not animate. Here we are. So what did I want to tell you? So ship count. Yeah, so composition is basically everything starts from the main ship. I decided I would start with a massive rectangle in the middle and then go from there. So have all the other ships line up around it. And so let me, here, I'll show you what a no ship composition looks like. If I can find the line, here it is. Search will help. So ship count. And so the main ship is basically a large rounded corner rectangle. Sometimes it's full, sometimes it's empty, and now we're only seeing empty ones because obviously this is oh, here it is. It's a demo. And so what happens is right after I create the ship in the middle, I start randomly throwing these lines around the space, and I place the other ships around it. So let me, I wrote a little debug code especially for this to show you the lines. I did write down those line numbers, so I should just hop there right away instead of searching. Here it is. So special behind the code. So yeah, you can see them from this one. It's more visible when we get an empty ship, and I'll show you there's subtleties in the placement of these lines. When so what happens is there's three modes of let me zoom back to the other presentation. So I wanted to make the composition interesting, so I thought of these, not sure how that came about, but I thought of these three organizational modes, where one would be kind of a gang mode where all the ships would be together, really close together, and we would only throw 3 directions, and then a mob mode where we throw 5 directions all over the place, and you'd have variance of 30 degrees to place the ships. And then this anarcho panda mode, which is just no directions, ships are anywhere and random, and anything goes. So so you can see this one is kind of it's the first mode, it's the gang mode. So you get these really tight directions, and then the baby ships, they align along those lines, and there's the variance you see in randomness of these lines is just a random 15% variation. And one thing that one problem I had to solve was that when the ship is full, and when you have the mothership covering most of the space because it's full and you don't see through it, I wanted to not go and place ships behind it. So I limited the direction to only place ships in front. And I can show you the algo for that. It's basically just a, whoops, it's really jaggy here. Let me, so random unit vector. So this is a small function that randomly finds a vector in the space, and it basically finds a new direction randomly in 3D space. And there's an argument that you can pass if you want or not, and it limits the z-axis. So as I'm generating this this piece, let me find an empty one so that we can see it clearly. Yeah, here we go. So as I generate this, the z-axis is coming towards you. So if I allow ships to be placed in the back, you'll see that there's directions going in the back, and then it creates a really nice effect where if the main ship is empty, then you'll have these small baby ships in the back, and it'll give it a different sense of depth. But when the ship is full, I didn't want to have all these wasted ships in the back, especially when in a composition that has only 3 or 4, really wanted all the action to be in front. So I limited the z-axis to it. Yeah, I can probably show you that code as well. It's not rocket surgery, but it's yeah, could be interesting. Position ship. There we go. So this is the position ship method, which chooses a direction, and then so as you travel on one of those directions, the ships I try to place those baby ships exactly at the same place as the mothership, and then I'm going to loop over that direction until the baby ship finds an empty spot in space. So it's always this intersect with baby ships is always false in the beginning, or it's always true. Sorry, and then it advances along that direction until it can find a spot. So it's kind of a lo-fi, rectangle stacking algo in 3D space where it'll just kind of exude and come at you until it finds a spot, and then it places the ship there. And then the next one will go even further and further and further. And one other issue I had was that eventually I couldn't really predict how many ships were going to be there. And sometimes the angle was really tight, so the ships would come right at the camera and then blow in the camera, and then I would have these previews that are completely full. So I decided to drop to calculate a max, I think is 6.2. Yeah, exactly. So the whole space here is about 10 by 10 by 10 in 3GS space. So when the ships are lined up and they come at you, if there's anything that's further than 6.2, I'll just drop it, and which is really just a hard-coded value that says, well, don't block the camera. Let us see the art. So I'll show you the lines in gang mode because that's probably the most visible. Let me hard code the PRNG here, and organization. There we go. So if I hard code the org to gang, and you'll notice that it's not very optimized code. It's very, very verbose, and there's comments everywhere, and it's very the variable names are long and everything. So here we go. Let's do another one. Did I save this? Yeah. Wait. All right. Doesn't seem to be working. Okay. Oh yeah, sorry. Wrong line. I'm sure someone's yelling at the video now going, you set the org at the wrong spot. All right, here it is. That works. All right, so this is so the gang org will only choose 3 directions, and they're going to be pretty tight. So you'll see a here. Let me pull back here. You usually see something that's a composition where they're all in one spot, and these are probably my favorite ones because they're kind of light, and they have all this empty space, and there's always a bend to them. They're always kind of the weirdest mints, especially when you get these really small shapes. That's another thing. There's a bias to the size of the shapes, and this one has really small ones. You get a sense that you're drawing in the same place, and all the ships are together, and they're hogged together, which creates these nice effects, I find. And yeah, I think that's it for composition. It's as I said, it was not something super complicated, but kind of effective and a lot of fun to play with. Okay, let me kill those blue lines. Yeah, I have them there. And so lights and color, second subject I want to talk about. I forgot to check time before we started, so I have no idea how if I'm going fast or not. But anyway, Pompey, feel free to jump in and let me know if I'm going too slow, too fast, or.
No, you're doing great. You're at 16 minutes.
Perfect. Okay, sounds good. Okay, lights and color. So let me show you what's really what Zupermat's really made of. I made this especially for behind the code. I made this totally white color palette. So it's right here, and so I'll set that to. And the palette is really it's colors. It's gels over lights. So basically what I'm doing now is I'm just telling the algo to render everything with white light. And maybe it's something I should have put in. I mean, I just played with it now, and it's kind of fun. The black and white is certainly something that's popular in art block circles. So yeah, this is Zupermat with white light. It's all white objects. It's either cement or foam core or plastic, whatever your mind wants it to be. And and you'll see that there's a small yellowish tint to it, and those are the hard-coded sunlights that are a point light and a camera light that light up the scene just to make it natural. I decided on a kind of sunnish color that's yellowish, and it lights up the space, and that's probably the only hard-coded color in there. The rest are based on the color palette. When that color palette is kind of simple. I started playing with a lot of colors, and it got really brown really quickly, a lot like paint. If you add too much, or if you add these opposite colors, it gets really muddy quickly. And I had to really limit the not only the number of colors, but how they interacted. Yeah, I'll show you this now. We'll go through every single. There's about 5 lights that light up the whole scene, and I'll go through them. And yeah, so another aspect of lighting is time of day. So I have this color palette structure here, which has the name, the color, and background color is almost not used, only when there's a big square in the back. And then the spot color, which is what lights up sections of it. So, and the algo will only choose 2 colors out of these 4 or 5 colors. And sometimes there's only 2 colors to choose from, like this one, like soap bar, mud bar. And sometimes there's 4, but mainly you'll choose one. It will choose only 2 colors. And with some palettes, I allow the algo to select the same color twice. So you'll get this monochromic, really, single color effect. And sometimes I allow it to, or sometimes I even force it to take different colors, because I find that these the palettes are kind of flat. So for Royalty and Royalty plus plus, which is a kind of, one is really gold and the other one is velvet purple. These palettes are so they're so flat that I force the algo to take a second color, because if it selects only the same purple, it gets it looks really flat. So yeah, so the other thing that interacts with lighting is time of day. So the algo will choose a palette, it'll choose a time of day, and then from there, it will play with the lighting and light up the whole space. And that's what will essentially generate different colors every time and different combinations. So you can have, say, a Royalty palette at dusk, or a Royalty palette at dawn, which will look very different. So getting back to lighting. So these two inputs come into the lighting, and lighting is the boringest piece of code you've ever seen. There's nothing in there but declaration of color features. So but the magic happens really beforehand when it selects the randomness out of it. So here's the piece of code that I was telling you about, where if it's F, I added this really at the end. So I was really I wanted to pay less gas to upload the script. So I really got I was trying to get the variables shorter, hence the F for flat. And yeah, this is, it says, well, if the palette is a flat palette, and that's kind of hard coded, then don't choose the same color, like extract the first color and choose a separate one. So yeah, first thing is ambient light right up top here. So ambient light is basically just this white light that kind of gives you an overall lighting. And the intensity of that light will depend on the time of day. So let's, I can't really hard code it here, but let's find some then. So if you have let me refresh this. So this is probably a dusk, because it's kind of darker, and I'll find these. Yeah, again, dusk again, and see these are dawn. So the lighting is really lighter. So there's more ambient light, and it gives it this the colors are less saturated, and it's the same palette, but it gives you a feeling of lightness and morning, basically. So what happens after the ambient light, which kind of lights up the whole thing, is I'll select two colors from the palette. I'll select the top color and the bottom color to put it into a hemispheric light. So hemispheric light is a lighting that is half and half. So it lights up the top of all the objects with a color, and it will light all the bottom of the objects with a separate color. And this is really what gives it all the structure, and where for this one in particular, you'll have, let's open the controls at the top here so you can see them. So the top color is blue. So it lights up everything with this harsh RGB blue, full blue, and it lights up the ground with RGB red. And then the combination of these two things gives it all those tints, and the combination of the ambient light will give it all that structure. So as we change palettes, sometimes I allow it to have those two same colors at the top and bottom. So, and this is also a nice effect that you get when you mix these colors. So for the hemispheric color of these two, the ground and the top is red. So everything usually should be normally red, but then there's a third spot color, which you can see on the right here, which is cyan, which kind of, since it's the exact opposite color, it dulls everything, and it creates this kind of brownish beige, which is a nice side effect. And there's the color you see of these objects, that pink and the brownish beige that's in there. These are colors that I've never chosen. They're not in the palette, but it's the composition of all the lighting that makes this these lights come out. And when I stumbled on these kind of brownish grays, I was really, it's something I really took care to keep as I was changing lighting and controlling. Sometimes you lose certain aspects in the randomness, and you gain others. And this is one of the features of Zupermat I really wanted to keep, is that that kind of mud that happens when you have these opposite colors that collide in the randomness and selection of colors. So directional light is also a random color that's selected, and that's, in this case here, it's a kind of a bluish cyan, and that will either, in some palettes, will highlight the colors, will either add more saturation, and it's just a light that's projected on top there. And then the two last ones are hard coded. Basically, it's the point light for the sunlight, and the only thing that randomness plays a part in here is the axis, the y-axis. So if it's morning, I'll place the light in the top. If it's day, I'll place it in the middle, and if it's dusk, I'll place it at the top. And it's just to give it more variability. And one light that I had to add right at the end is that when I started playing with animation, I had this issue where we would visit an object, and then we'd be behind. So we'd be behind here or something, and then there wasn't enough lighting, and it would get dark, and you wouldn't get the sense of contrast that I needed. So I added this kind of flashlight right next to the camera. So this camera point light here is a camera that's initialized here, but eventually we'll see during the animation that every time the camera moves, that light follows the camera, and it highlights a section of Zupermat that the camera is pointing at. So an extra little bit. So yeah, as you can see, a lot of experimenting, a lot of this whole thing took a while to get right, and to get to a point where it wasn't a rainbow of colors, and it was just enough, and it was also properly lit in all aspects. One thing I had to do at the end that I felt kind of bad about, but I think it served the piece properly, is I had to play with the time of day for certain palettes. I couldn't allow, and it's right here, so here's that little hack. I named some palette to be too light. So I said, well, these palettes, they're just, they burn easily. So they have too light, the colors are too light. And then when you have them during the day, with the time of day that's day, it blows the colors, and there's not enough saturation. So I hacked it very nicely, where I replaced day with dusk, I think. So you have, for the L palettes, and we can go see them at the top. I think there's 2 or 3 of them. There they are. So those L ones here. So Sliver is one that's too light, and Pastilleria is one that's too light as well. For these two, then the time of day, the day here with day 0, what I do is I'll take a dusk, and I'll hack the probabilities to put 2 dusks in there. I hit the mouse, sorry. And yeah, so I'll replace the day with the dusk, and then you'll have 2 chances of getting a dark one instead of a day one. And yeah, that's how I got out of that little overburnt lighting. So yeah, so no magic formula, nothing fancy, just gels, experimenting, combining, and then combining the time of day with the palettes always gives me a different colors, different lightings, which I thought was a nice way of, being surprised myself every time I see a new one. So yeah, I'm just going to refresh a few times for fun. Take a little pause and take a sip of water. Oh yeah, a small rounded one, rare. Let's go see. Don't see those too often. What's next? Okay, so yeah, I shut off the animation, but we're gonna bring it back to to show you how so you see all as I was working on Zupermat, that's what happened. I was playing with it every day, all day like this, trying to find like, what do I want to say? How will this look calm and supreme and aesthetically pleasing? And I couldn't never decide, or I couldn't find the right angle every time and say, well, this is the way to calculate the right point of view. This is, for this piece, the right point of view is this. And for this piece, the right point of view would be, if I placed myself here and I zoom in a little, and I said, well, and I was having so much fun navigating the pieces that I thought of incorporating the navigation in there. But I didn't want the user to do it himself. I wanted the piece to be autonomous and to, speak its own language and to be able to be displayed on a screen and to be alive without having someone interact with it or be there with a mouse. I wanted the piece to be, kind of like a breathing, living element. Don't have the right word for this, but I wanted to have a life on its own and to be autonomous. I think is probably how it conveys that desire. So I started playing with animation, and I'll just drop down to the animation code here. It's right at the end. If you've ever done 3GS, so 3GS is fascinating. It's a really nice way of having access to a 3D environment, and it abstracts out a lot of the complexity that you've seen in an early episode with other artists, where you can see that making 3D art can be very complex with ray tracing and everything that surrounds that. So 3GS abstracts all this out to you, and you can play with objects, play with lighting, play with camera angles, play with shadows. As you can see here, when it's dusk, you get these nice shadows that are added. And also animation. So super fun to use. Let me get down. I wrote down the line number here. Let me, so 7, much lower, 600. So a large piece of one file code. Backplane, not so interesting, but it exists. One other issue I had was that adding animation to this, sometimes you'd have pieces in the back. So if you want to navigate to the small ship in the back, then you can't really have a backplane. It can't be, you can never end, right? You have to travel in this space in 360 degrees. So when there's a background, I had to engulf the whole thing in a large sphere. So now we're outside the universe looking in, which is rare. And so it's inside this massive sphere, which gives it this nice lighting. And then, so when you travel around it, you can see, you never run out of background. So back to animations. So camera, here we are. So animation, where to start? So one issue I had was where do I go? Where do I point the camera to make this interesting? What's fun to look at? And what I was doing when building Zupermat is I kept going to these smaller ships and zooming in on them, and checking positioning and making sure that everything lined up right. And sometimes you get the lighting that just shines through it, and super fun. So all that I wanted to bring forward. So I used the composition in a sense to guide the visit of the sculpture or of the composition. So I'm basically using all these small ships to bring the camera towards them. They kind of attract the camera for a while, and then they let the camera go and it comes back. So yeah, okay, forgot to add back the animation. So let's do that. Do animate. Do animate. Let's bring that back. Oops. And I think that works. Yeah, it does. It's a little jaggy, but that's fine. Okay, so let's go back to the animation code. So animation. So I'll speed the animation up so we get a sense of what happens there. So I ended up choosing an animation time that's about 12 seconds and used pi for that. No idea why. Just multiplied pi by 4. I think a lot of animations I did earlier were like around sine waves and around cosines, where you get these rotating effects, and then pi was just a natural clocking element. So that's the animation time. So let's bring it down to say 3.14 seconds. And it's kind of jaggy, but okay. So it moves. And so that's the cycle time is about 3 seconds here. So that's what I set right here, cycle length. And then what I wanted to do is to, when you see the animation, when it opens up, I wanted the animation to start right in the middle of it, because I have this easing function that kind of starts the animation slowly and ends it slowly and restarts it slowly. So I didn't want it to start from 0 and to have the viewer come into the piece and be, how can I say? I didn't want him to wait. I wanted to be kind of surprised by the piece where it's already in movement. So I added this little offset here of, I have no idea why it's 0.38. I think I just tried numbers, ended up with, point. It's, it means start the cycle 38% into the cycle. So 38% of 4 times pi. I'll let that as a exercise for the viewer. So what the first thing I do is for the animation is you wanna get a sense of where you are, how much time has elapsed in the whole animation, and so it calculates at which cycle you're in. So every time it moves, it's a different cycle. So 1, 2, and then it'll go with a 3rd cycle now, and then a 4th cycle now, and then a 5th cycle. And then that's how I keep track of where you are. So we'll skip this little if now because it's not useful. But so the basic animation, it's really just lerping the camera vector. So what happens is I calculate where I am in the cycle. So I mod the elapsed time by the cycle length. So now the cycle time is how far am I in the current cycle. So and then from that number, which is essentially going from 0 to 1 in the time of one cycle, then I can calculate the camera position. And 3GS, I was saying before, 3GS extracts a lot of these calculations out, which makes it super useful to work. So you can just take the camera position and lerp 2 vectors together. So what I do is I have the start position where I was before, the end camera position where I want to go, and then I use an easing function to make it kind of move smoothly. But essentially, it just calculates a different vector for every cycle, and it moves the camera along that vector. And yeah, one thing that's really important is to look at the flagship. I've never done this before. Let's comment that out, see what happens. And then, yeah, the light I was telling you about the flashlight that's next to the camera. So I drag that along. So I'll copy the camera position with the light. So one thing that's really nice in virtual environments, you can have the light right in front of a camera and it won't matter. There's no actual wire or anything. It just projects light. So I'll put it right in front of the camera and I'll light up the scene from there. And I'll also update the look at position so that the light points in the right direction. So let's save this, see what happens. Or probably, yeah, kind of go other places to look at different things. It's not that bad. turns out I didn't really need that line. Yeah, I think it probably starts looking the wrong way at some point. But yeah, not that much, surprising. What else? Yeah, so that's basically it. It's yeah, the animation uses the. Oh, I have a small added some debug code here too that we can I think look at. I think we have a little time. I have this yeah, ship coloring function that I can use. So I'll color the ship yellow so that you can see as it visits a ship, it'll just highlight it yellow so that you can see where it aims. And I'll at the same time I can look at the code for this, which is which might be interesting. See, it went to look that guy, and then comes back. Ooh, go in there. Okay, so yeah, let's go back to the animation code here. So what happens is every time, you remember when I said we'd skip that if, so every time there's a new cycle, it says, okay, well, it's a new cycle, so choose a new camera position, like go somewhere else, go visit the piece from somewhere else. And it will clone the camera position that it's at and say that this is my new starting position because it's my old camera position. And then it will say, well, you know, from the pseudo random number generator, generate me a new camera position that's interesting to the viewer. So it gives, calls this method right here. And this method is basically, I wrote it at the top yesterday. So it 66% of the time, so 2/3 of the time, it will show you a global view of the piece. So it'll be a view that's from far away. So you'll be, the make preview position is a view that's kind of really restricted and on the z-axis. It's basically you pulling back, like you're in the museum, you pull back from the object and you're looking at it from afar, kind of like the position that it's in now. And then for a third of the probabilities, because RB here is a Boolean random function that says be true 66% of the time, and then the rest of the time 33% is false and it falls through. So it's so when it is false, it says, well, we're in the 33% of the cases. So pick a children in all these ships, and from that ship, get the position right here. So get the ship position, and I think it randomly. Oh yeah, so from the position's length. So the position length is really from the 0 point of the composition. It draws a line. So it's basically the vector in 3D space where the ship is. And it says, well, calculate me a position that's from a little further away, so in front of that object, and all the way up to 9, because I told you before, the whole space here is probably 10 by 10 by 10. So place yourself either really close to the object, so 0.5 in front, or about 9, which is about that length, that what we're seeing now. So choose one, go in front of it, pull back randomly, you know, be super close. Like this is not too close to the object, right? But this is super close. So randomly it says, well, I want to be really in the face of that ship, or I want to be, you know, kind of far away. I want to be in front of it, but far away. And then, so that new position that you've just calculated, set it to, or send it back, or it returns it to the animation object, the animation function, sorry, and it uses that as the new position. So let's change here because we're all kind of getting yellow. And it's surprising how long it takes to visit all the ships. I'm not sure if you saw before, but there was only 9 ships in there, and it only visited 6 or 7 of them, or not even, I think 5 of them. So yeah, oh, small ship hidden here. And I don't know why I call these things ships. I think I have this spaceship metaphor in my head that I have to explore more. and they're the mothership, the baby ships. It's all very family oriented, this art. What else? I think I'm done. I think I've covered everything I wanted to say. Yeah, lerp camera position. That's the magic. And yeah, keep looking at the mothership. Do not stray from the mothership. Those are my final messages. I don't have a conclusion, Pompey. So
No,
if you have
amazing.
any questions, yeah, I'm open.
No,
Yeah,
this
thanks.
was great.
Right.
You know, at the start, I love seeing the directional lines from the source. I feel like the mints always felt as if the ships had momentum, but then it becomes so much more obvious with the lines. So it was cool to see it come from the
Oh,
source.
thanks.
I actually had a question about the light sources. So there was a sun as well as a camera light, and I think you said 5 sources in total. How did you choose the maximum number of sources to include?
Oh, I have no idea. I think let me get back to what my thinking was. I think my thinking was, let's use as little as possible. And and as I was pulling lights out, it gets boring. It gets flat and it gets boring. And so I had you kind of need to ambient light. It's kind of a given. You need to light up the whole thing. So that one was obvious. And then the hemispheric light, the one that's top and bottom, is something that that I think all the color came from. So I couldn't get rid of that one because it was so important to the coloring and to the feeling of it. And then yeah, the point light, the sunlight, it was so fun that sometimes the ships would have this highlight, like you'll see, like right at the bottom here, you'll see this small highlight come through, and yeah, I couldn't get rid of it. And another aspect is computationally, lights are pretty expensive. Some lights are more expensive than others.
Mm-hmm.
So ambient light and hemispheric light is kind of cheap, and but all these directional and point lights, they're more expensive. So I wanted to be to not use them too much so that it would render, so that it would allow animation. So yeah, I think my goal was to keep it as light as possible, and yeah, and I couldn't get away from adding that flashlight at the end, because yeah, sometimes you'd get to a small ship and it was just flat because all the lights were on the other side of the piece,
Mm-hmm.
and you'd see just this big blob of red or blue, and it was uninteresting. So having the flashlight right next to the camera would give it this kind of, gradient that you would feel the piece, you would feel the 3D aspect of the shape. So
Definitely, and I feel like with the animation too, it almost feels in combination with the camera light that we're inspecting the piece.
yeah.
And so I think of a fact that I mean I learned for the first time, and I think a lot of people are going to see for the first time, is that the pieces are actually engulfed in a sphere.
Yeah.
And so can you speak more on the importance of incorporating that, if there were alternate approaches you considered?
Oh yeah, for sure. Yeah, initially I my initial, like, I can probably show you on those initial screenshots. My initial I think when I started on, even when I started on Robson, I think I had this idea that the sculpture had to come out of a paper, of some kind of plane where it would pop out of a kind of a paper or a backdrop. And pretty quickly, all my backgrounds were white and black. And something that came out of speaking with, well, you guys at Art Blocks and talking about the Robson Mint was like, well, the backgrounds are kind of always the same and they're a little flat. And so I wanted to expand that piece of paper and make it disappear. And it didn't work, because at some point the camera would go in some angle and you would see that piece of paper finish in infinity, and you'd be like,
Mm-hmm.
what is that artifact? It would break it would kind of break the animation and the fact that you're all engulfed in this environment. So yeah, it's the only way I found to make sure that you always have that really nice background that circles the whole environment, is to create this massive sphere around it. And I think what ended up happening is that I put the sphere everywhere because it would solve all these issues of what if randomness sends the camera behind the piece and then you're looking on the other side and it's just black or white, and it would kind of breaks the flow of things. So I wanted you to feel always that you're inside that little universe of and you're traveling, visiting the piece.
And so in watching the animation, I feel like you could potentially watch it for hours without the sense of it repeating. So that makes me want to ask the question, does it ever repeat?
No, not supposed to. If
Amazing.
randomness, well, it's pseudo-random, so eventually you might get the same angle, but it's every time. So I can probably go to that function and next camera position here. It selects it. The positioning of the camera has some element of randomness, so it will always be a different posture, a different length, or it will never be the exact position. But I think you do. I mean, you do get a sense of repetition at some point because maybe the same piece will be visited twice, maybe from almost the same angle.
Mm-hmm.
But you'll probably come from a different place. So you'll end up there, but the movement will come from somewhere else. So the movement is designed to be always different, and it's in a sense it uses that the pseudo random number generator at infinity, right? You're not calculating all the features and setting them in stone and then using them to render the piece. As long as you're viewing the piece, then you'll discover these new numbers, and in a sense, it's, I guess, pseudo infinite.
No, definitely. I mean, even just watching this mint you have pulled up, I mean, this has been running for some time now, and I just saw two separate ships get colored. So it definitely, I know, I just love the idea of it, like almost running in perpetuity with a sense of randomness. But that's the last question I have, Phil. I want to say thanks to everyone who will be watching this in the future, and a very special thanks to Phil for speaking on his project Zupermat. Till next time, be great and happy minting.
Thanks, Pompey.
Of course. See ya.
See ya.